Hello, good evening everyone. Let us take this question of the day, which is going to be very helpful for your entrance exams for MSc Statistics. Show that the sequence is bounded, right? So the sequence given to us is n upon n plus 1. In the last lecture, we saw that a sequence is bounded if it is both bounded above and bounded below. So we need to prove that this sequence is both bounded above and bounded below. Let us start. We have written an as n upon n plus 1, and the numerator can be rewritten as n plus 1 minus 1 upon n plus 1. So we have just expanded the numerator, n plus 1 minus 1. Plus 1 bhi kiya, minus 1 bhi kiya. Now we can open this up and write this as n plus 1 by n plus 1 minus 1 upon n plus 1, right? So n plus 1 by n plus 1 cancels out and it gives you 1 minus 1 upon n plus 1. Better think about it. Whatever value of n you will put in the natural number, you can put n as 1. What will you get here? You will get 1 upon 1 plus 1. That will be 1 by 2. You can put 2, you will get 1 by 3. You can put 3, you will get 1 by 4, 1 by 5, and so on. Whatever value of n you put, whatever value, you will get some number. You're subtracting something from 1. You're subtracting something from 1. If you're subtracting something from 1, it must be less than 1. So we have found out that this sequence has an upper bound of 1. It cannot exceed 1. Right? Is this clear? Now, beta, your natural numbers can only start from 1. N can be 1, 2, 3, 4, etc. And I told you that whenever we make sequences, we make it for natural numbers. So the n value can either be 1 or greater than 1. We are clear with it? I can add 1 on both sides. If I add 1 on both sides, I will get n plus 1 greater than equal to 1 plus 1. So n plus 2 greater than equal to 2. Better tell me something. If 4 is greater than equal to 3, then when I reciprocate it, 1 by 4 will be less than equal to 1 by 3. So if I reciprocate it, 1 upon n plus 1 will be less than equal to half. Right? Now let me multiply with minus 1 on both sides. What will minus do? It will reverse the sign. So minus 1 upon n plus 1 will be greater than equal to minus half. Now I can add 1 on both sides. So 1 minus 1 upon n plus 1 will be greater than equal to half, because 1 minus half is just half. Okay. This is nothing but n upon n plus 1. This was my sequence. So n upon n plus 1 will be greater than equal to half. So we have proved that all values in our sequence will be greater than half. Right? So what have we proved? We have proved that all values of sequence will be greater than equal to half and it will be less than 1 strictly. So the sequence has a lower and an upper bound. That means that the sequence is bounded because it has both lower and upper bound. So we have proved that this sequence is a bounded sequence. Okay, beta. Thank you.